Okay, so this video is going to look at equations that have fractional exponents, like the one we see here, and also equations that have radicals, because they can be solved very similarly. So to begin with, we need to make sure that we're isolating whatever the thing is that's being raised to the power. So in this case, since 3x is in parentheses, that whole quantity is being raised to the power. So I need to start by just getting that expression by itself. So I'm subtracting over the 5. I still have 3x in parentheses to the 2/3 power. Now this is equal to 4. Okay, so now I can't do anything else. I can't divide by 3 until that power is out of the way. Right now it's really sort of trapping what's in parentheses. So now I'm going to use the reciprocal power to knock out the original power, and of course if I do it to one side I have to do it to the other. These multiply back down to 1, and if we have something with a power of 1, we don't even really need the exponent or the parentheses anymore. So now I'm just left with 3x equals, this I would put in my calculator, so if you're typing this in you'd want to do 4 caret and then put 3 over 2 in parentheses, and this should give you 8. Okay, so now we divide both sides by 3. This isn't going to come out as a whole number, that's okay. You're going to get a decimal if you put it in your calculator, so I'm just going to leave this as 8 over 3. Now the one thing you do need to be careful of, the only really catch when you solve these equations, is that technically, when we just took 4 to the 3 over 2 power, we really, if you remember our fractional exponent rule, this is really the square root of 4 cubed. So technically, when you take a square root of a whole number, it really could be positive 2 or negative 2, and that's the number that we're cubing. So if you think about the fact that negative 2 squared gives 4 and positive 2 squared gives 4, that's why we have to account for this whole positive negative thing. And this only works with even roots, so in this case it's a square root, so that's really a little 2 there. It wouldn't be an issue if we had an odd root, because we know that when you multiply a negative number an odd number of times, we actually can get a negative answer. So this is only an issue when you do have that positive number in your root. So anytime when you take your reciprocal power, this number right here is even, you just have to make sure that you have a plus minus in your answer. So my final answer is x is plus or minus 8 over 3. Okay, so now let's take a look at a radical equation. So here's an example. We actually really have the same type of situation. So technically, if we want to look at this radical as a fractional exponent, this expression is really being raised to the first power because there's no power there. And since it's a square root, that's really a 2. So I'm going to go ahead and rewrite this. Instead of having a radical, I'm going to write this as a fractional power because I just showed you how to do those types of problems. So we're just going to keep the strategy exactly the same. So in this case, I'm going to change my color. This is the whole expression that's being raised to a fractional exponent. So that's the thing I need to get alone. So right now I'm going to go ahead and move the 6 over. So now I can't subtract the 4 or divide by 3. I can't do any of that. Kind of like I mentioned on the last slide, this whole thing in parentheses is trapped by that exponent. So until it's gone, we can't solve any further. So again, I'm going to go ahead and use my reciprocal power, which in this case is 2 over 1, or technically we're really just squaring both sides. You don't have to put the 1, but I think it just helps you see the idea of a reciprocal. So these are going to knock out, and now I'm solving this. If you square negative 2 in your calculator, you should be getting positive 4. Make sure in your calculator you're putting negative 2 in parentheses, and now I'm just going to solve. So I get that 3x is 0. So if I just kind of go up here to finish this off, I would divide both sides by 3, and I get that x is 0. Okay, so that should be my answer. However, when we solve radical equations, we always have to check, and that's because anytime you do something to an equation, such as squaring, this is a really common example, you can create what's called an extraneous solution. That means a solution that, even though you did everything right, when you plug it back in, it doesn't work. So we do have to kind of be careful here. So I'm going to go ahead, I'm going to go back to my original, so the equation with the radical, I'm going to plug in the answer I just got. So I'm going to plug in 0. I'm a little squished here, but make sure you're keeping that plus 6 on the outside of the radical. That's not part of it, and this is supposed to be equal to 4. So you can do that in your head or you can do it in your calculator. If you are going to use your calculator, just make sure that when you open that radical, you're closing the radical after you do the plus 4. So you're going to need to actually close the parenthesis for the radical and then add the 6. And when I do that in the calculator, I actually get 8. Which is not equal to 4. So that is not true. So x equals 0 is actually what I mentioned. That's an extraneous solution. So our real final answer to this equation, you can do this fancy way of saying that the empty set is the solution set because there's no numbers that satisfy it, or you could just write the words no solution. Either way is fine with me. So that's why we always check radical equations. I do want to do one more radical equation on this video because sometimes these examples can be a little bit more complicated. There can be a little bit more algebra involved. So in this example, I'm going to do the same thing I did before. I'm going to treat this radical as if it really was a fractional exponent. This is going to work the same every single time because these are always square roots with just powers of 1. So this is really x minus 2 to the 1/2 equals 2 minus x. Okay, so there's no isolating I have to do this time. The thing that's being raised to the fractional power is all that's over here. So again, I can't add that 2 over until I've taken care of that 1/2 power. So at this point, I'm going to go ahead and raise both sides to the reciprocal power. Again, this is really squaring, but you can put that 1 there if you want. So these are going to knock out. Here's the catch. When you square something like 2 minus x, I cannot do this. That's a no-no. So instead, I have to actually write it twice. Because remember, squaring really means multiplying by itself. Now I'm going to have to double distribute. So I'm going to have a lot of algebra here. So x minus 2. When I 2 times 2, I get 4. 2 times negative x gives me negative 2x. Negative x times 2 is another negative 2x. And then finally, negative x times negative x gives me positive x squared. Okay, so you can kind of see at this point you should be kind of thinking, okay, I'm heading toward an MAM problem or a factoring problem. You're going to want to combine any like terms that you have and also get everybody on the same side. So right now I'm going to go ahead and combine these like terms. I have a negative 2x and a negative 2x. So this is x minus 2. I'm also right now going to go ahead and put everything in the proper order. I typically have my x squared first, then this combines to make negative 4x, and I'm going to put that plus 4 at the end. I just reordered everything so that it's in an order I'm more familiar with. Now I'm going to have to move both of these over, so I'm subtracting an x and adding a 2 to both sides. So I now have my equation set equal to 0, which is what I always have to do if I'm going to factor. So I end up with this. So now I'm ready to go ahead and do MAM. I'm going to go onto a new slide just so I have enough space. I'll just rewrite this. Okay, so if you remember MAM, we're going to go ahead, let's put the letters on top so that we remember how this works. So this means, since there's technically a 1 here, I really need to multiply to 6 and add to negative 5. So now you're trying to think of numbers that are going to satisfy those criteria. I know 2 and 3 sound like they're going to be pretty good here, but in this case, since I want to add to a negative, I'm going to actually have to make them both negative because that's how I would multiply to a positive number. So I'm going to have x minus 2, x minus 3 equals 0. Okay, and you guys remember, you drop and split now. So you're really setting both of these equal to 0, which is really just going to change your signs. So that means for right now, my two answers are that x is equal to 2 and x is equal to 3. But again, remember, we always have to check radical equations. So I'm just going to flip back quickly to see. I'm going to go ahead and rewrite my original problem and then plug both of my solutions in. So I'm checking that the square root of, in this case, I'll start out by checking 2, of 2 minus 2 is supposed to be equal to 2 minus, and again, I'm substituting in my answer of 2. So this is what this is going to look like to start. So this is saying that the square root of 0 is supposed to be equal to 0, and that's true. So that solution checks out. Now I'm going to do the same thing. I'm going to put in that 3. So again, x minus 2 in this case would look like 3 minus 2. And on the other side, it's supposed to be 2 minus x, so 2 minus 3. Well, again, if you put this in your calculator, this is really saying that the square root of 1 is negative 1, and we know that that's not true. Square root of 1 is positive 1, and that's what your calculator will give you if you plug it in. So it turns out that x equals 3 was an extraneous solution, and x equals 2 is my only answer. So if you want to just box it, or you could also do a fancy solution set and just list 2 only, because that is the only one that's an actual solution. So that's another example of a radical equation, but it does have, as you can see, a lot more steps because you started out with algebra on both sides. So that's it.